Okay, let's start with the definition of reference angle. So the angle formed by the terminal side and the x-axis is called the reference angle. So let's look at the example down here in the lower left-hand corner. And so the first thing you'll notice is we've got a terminal side. Let me change these colors really quick. Okay, so the terminal side is the side where the angle terminates right there. So that is the terminal side. And you'll notice that you can approach the terminal side either as a positive angle by rotating counterclockwise or as a negative angle approaching it clockwise. The reference angle is the angle between this terminal side and the x-axis right here. So this would be the reference angle, which looks kind of like a slice of pie or a slice of pizza. So you're looking for this slice of pie or slice of pizza in terms of angles here. Now, one thing you'll notice is that the reference angle is always going to be positive. And it's always positive, and it'll be either between 0 and 90 degrees or between 0 radians and pi over 2 radians. So the reference angle is always going to be positive and between 0 and 90 degrees or 0 and pi over 2 radians. Now, there will be a time when you practice this enough that you'll develop the number sense for this mathematical concept, and you won't need formulas anymore. You will be able to look at it and kind of determine how you need to calculate the reference angle, how you need to calculate a coterminal angle, and so on. But until then, I'm going to provide you some structure. I'm going to provide you with some formulas that you can follow. Follow the formulas until your brain starts to see the pattern. And when your brain starts to see the pattern, you won't need the formulas anymore. You'll have number sense for it. Okay, so what are these formulas and when do you use them? All right, so what you can see here is that I've given 4 different scenarios, and those 4 different scenarios depend on where the terminal side ends up. Okay, so if the terminal side ends up in the first quadrant, okay, you're going to use one equation for that. If it ends up in the second quadrant, you'll use a formula for that. If the terminal side is in the third quadrant, you'll use a formula for that. And if the terminal side ends up in the fourth quadrant, you'll use a different formula for that. So what formula do you use and when? And that's what I've put in these tables on the right-hand side. And I tried to simplify these as much as possible, and I tried to make them as much consistently the same as I could. So you'll see in this table that if you're working with an angle in degrees, check and see where the terminal side is. If the terminal side is in quadrant 1 and the angle that you're working with is positive, then the reference angle is just going to be that angle. If you're in quadrant 1 and the angle is negative, so that would look something like this, where your angle is negative, but you end up in quadrant 1, then this is the formula you're going to use. Okay, and so you can see in this first column, if the terminal side is in quadrant 2 or quadrant 3, then use this formula. If the terminal side ends up in quadrant 4, like this, then you're going to use these two. And just notice that quadrant 1 and 4, they're basically the same formulas, just kind of flipped around. Now these formulas work, but you have to remember always that the reference angle is always going to be positive. And that's why in this column, I've put the reference angle around inside of absolute value signs. Okay, those absolute value signs are meant to indicate to you that no matter how you use these formulas, okay, if the reference angle comes out to be negative, you need to have the sense to change it to positive, because the reference angle is always positive. All right. So that's really all that this page, is kind of meant to illustrate, is the reference angle is always positive. The reference angle is the angle between the terminal side and the x-axis, right? Terminal side, x-axis, terminal side, x-axis. It's always going to be between 0 and 90, between 0 and pi over 2. And I've given the same table here, but for radians. So you can see it's got the same formulas as up above, but now instead of degrees, it's in radians. And, I kind of presented the tables vertically this way, but I also made the same table horizontally down here in case maybe that looks better to you. Same information, same formulas, I just presented it in a different way. Okay, so what purpose do these reference angles serve? Well, to kind of get an idea of that purpose, let's look at an example. So, here we've got the x-axis. Let's see, what did I use for that color? Blue. Okay. So here I've got the x-axis, and I've got two angles. One, which is 60 degrees, okay, and I put the terminal side there in yellow, and another angle, which is 120 degrees. And so you can kind of see it illustrated here. Okay. Now, what you'll notice is that these two angles, okay, what's a little different than what you've seen before, is now we're taking the terminal side and we're intersecting the terminal side with the circumference of a circle. Okay, so we have this circular circumference, and where the terminal side intersects that circumference, these are the x and y coordinates at that point. So the x coordinate at this point is 1/2. So if we trace down to here, this would be 1/2 on the x-axis. And this square root of 3 over 2 is going to be this coordinate on the y-axis. So that would be square root of 3 over 2. All right, now that's for 60 degrees. Now, if we measure 120 degrees and we follow the terminal side up to where it intersects the circumference of a circle, then the coordinates of this point are also 1/2, okay, but negative, and square root of 3 over 2. So that's the interesting thing, is we've got two different angles, 120 and 60, and yet they both have 1/2 for x values, and they both have square root of 2 over 2 for y values. Why do they have, almost the exact same values between them, especially since one is 60 and the other is 120? It's because they have the same reference angle, right? The reference angle for 60 degrees is 60 degrees because it's in quadrant 1. The reference angle for 120 degrees, because it's in quadrant 2, that reference angle is going to be here. It's this pizza slice. And that reference angle is 60 degrees. So the reference angle for 120 degrees is 60. And the reference angle for 60 degrees is also 60. So their reference angles are equal to each other. And since they have the same reference angle, they're going to share the same x and y values. Now, true, this one's negative, okay? But still, the fact that they're 1/2 and square root of 3 over 2, both of them, will be an important thing to remember. These numbers, 1/2 and square root of 3 over 2, these are going to come up a lot in trigonometry and trig functions. And trigonometry and trig functions are closely tied, intimately tied, with the circumference of a circle, where the circle has a radius of 1. And a circle with a radius of 1 is going to have these values, 1/2 and square root of 3 over 2. So learning how to determine reference angles around any angle is going to be really important for trigonometry. Okay, so this idea of reference angles will be heavily used later. The concept, itself is somewhat simple. It's the angle between the terminal side and the x-axis, but it takes a little practice to get good at seeing it and calculating it correctly. All right, so that's the definition of reference angles. We'll look at some examples here next.